Welcome to the second module of HVAC 101, Air Conditioning and Refrigeration. AC is short for air conditioning. What you will realize after this video is whether you are cooling a space with AC or refrigeration, it is the same process. Both systems utilize the exact basic parts. Air conditioning is about comfort, providing cool, low humidity work in living areas. Refrigeration is about convenience, keeping foods cold and fresh. Okay, let's look at some different types of equipment that we have in the HVAC industry. This first piece of equipment is a simple household refrigerator. Next is a package AC. The last unit is a window air conditioner. If you look at these three units, you'll notice that they all have pretty much the same components. Every one of them has a compressor, condenser, an evaporator, and a metering device, which is not shown on these diagrams. Although they all have the same components, they do different jobs. The household refrigerator keeps food cold. The package AC unit will provide air conditioning for a larger area by way of ductwork. And then the window AC provides air conditioning to a single room. Let's discuss the common parts of all refrigeration and air conditioning systems. It doesn't matter whether it's a refrigerator, freezer, or an AC system. The main component of all refrigeration and AC systems is the compressor. Its two functions are to move the refrigerant contained in the refrigeration system around through the various components, and also to create a pressure-temperature difference between the condenser and evaporator. Keep in mind that the descriptions of these following components is very basic and that there is a much more complicated process in play with the refrigeration system. The next component of the refrigeration system is the evaporator. Shown here are two styles of an evaporator. The purpose of the evaporator is to remove unwanted heat from the conditioned space. The next main component is the condenser. The condenser's purpose is to get rid of the heat that was picked up in the evaporator and transfer it into a non-conditioned area, basically either outside or it could be located in an uncooled warehouse or some structure like that. The last component is the metering device. The metering device purpose is to control the amount of refrigerant entering the evaporator, and it also lowers the pressure of the refrigerant entering the evaporator. This metering device shown is a cap tube. There are many styles and designs of metering devices. If you notice, the evaporator and the condenser coil are very similar in design and shape. The way to tell the difference between the two is that the evaporator is always going to be in the conditioned space. And that's where you'll also find the metering device, right with the evaporator. The condenser is always going to be outside of the conditioned space. And another easy way of locating it is, usually, not all the time, but mostly, it's located wherever the compressor is. Let's look at some different types of refrigeration systems. The top left picture is of a commercial fruit and vegetable case. The top right picture is of a commercial reach-in display case. The bottom left picture is of a walk-in unit. And if you notice, the device with the two fans on it, that is the evaporator, because it is inside the actual conditioned space. That's where the food is. And lastly, on the far bottom right is a typical household refrigerator. Although they're vastly different, they all perform the same duty. They're keeping food cold. Let's take a look at some different types of air conditioning units. The top left is called a package unit. It is called a package unit because when you order one of these from the manufacturer, it comes with all the major refrigeration components, piping, and electrical wiring of a complete system. The upper center picture is of another type of package unit. The difference between it and the one on its left is pretty much just where it's installed. As you can see, it's on a roof. This type of unit is referred to as a rooftop unit. They sit on a base called a curb that includes ductwork to distribute the cool air to the conditioned space. The upper right picture is of a residential portable AC unit. They are self-contained units that can be moved around. If you notice in the picture the window vent attached to it, This is how they reject heat to the outdoors. The picture in the bottom left is of a ductless split system. It is designed so the condensing unit, which contains both the condenser and the compressor, is outside, and the evaporator is mounted on a wall in the conditioned space. Since the components are separate, an HVAC serviceman will need to connect the piping and electrical work between the two. These units do not use ductwork. They only cool the room they are located in. The bottom central picture is of a split central AC system. The condensing unit is placed outside, and the evaporator coil is placed inside the ductwork of a furnace. It uses the furnace's indoor blower, which is a device similar to a fan, to distribute the air through the ductwork to the building. The picture on the bottom left is of a window AC unit. All these systems, though designed differently, work the same as all other refrigeration systems discussed so far. Now that we have discussed the types and components of AC and refrigeration systems, let's talk briefly about the refrigerants that circulate through them. There are many different refrigerants available today. Different systems will use the refrigerant that best suits its needs. An example of this is a freezer will use a different refrigerant than an air conditioner due to the vast difference in their conditioned space temperatures. Refrigerants are designed to have a very low boiling point temperature, be non-toxic, and non-flammable. There are some dangers and laws regarding the use of refrigerants that will be discussed in depth in other courses. All systems have a high side and a low side. If you look at the two pictures, you will see the dividing line of the high pressure side and the low pressure side. The metering device and the compressor are the actual dividing points of high and low sides. When refrigerant enters the metering device, it is a liquid. When it passes through the metering device, its pressure decreases, which causes it to boil. Remember from the previous module how a substance changing from a liquid to a vapor absorbs a lot of heat energy. So this boiling refrigerant will absorb heat from the conditioned space. Just like boiling water absorbs heat from the hot pot that is on a stove burner. The refrigerant in the evaporator will completely boil to vapor before it leaves the evaporator. This vapor will now travel to the compressor, where its pressure will be increased. If you remember, when we increase pressure, we also increase temperature. This high temperature, high pressure vapor now travels to the condenser. As it flows through the condenser, it changes state from a gas to a liquid. This change of state rejects a lot of heat to the outside air. The refrigerant that leaves the condenser will be now in a liquid state. This liquid will now travel to the metering device, and the cycle starts over again. In air conditioning and refrigeration, you will hear the term tons when talking about how many BTUs of heat transfer a system can achieve. A ton of refrigeration is the amount of heat required per hour to melt 1 ton of ice in 24 hours. So 1 ton of refrigeration is equal to 12,000 BTUs per hour. Please study these pictures for a moment to better understand this idea. When servicing refrigeration systems, we use gauges to check what the system pressures are. Our gauges read pounds per square inch gauge, or PSIG. This measurement does not include the pressure of the atmosphere, which is 14.7 pounds per square inch at sea level. Pounds per square inch absolute, or PSIA, includes the pressure of the atmosphere. So 14.7 PSIA equals 0 PSIG. Most HVAC equipment pressures are measured using PSIG, but some equipment does use PSIA, so it's important you understand the difference. When servicing refrigeration and air conditioning equipment, there will be times when you must achieve a deep vacuum on the system. A vacuum is when we lower the pressure of the system to below the pressure of the atmosphere. In past years, service technicians would use inches of mercury to read vacuum, and 29.9 inches of mercury was considered a deep vacuum. Due to stricter refrigerant handling rules and laws, a more accurate vacuum measurement was needed, so today we use the micron scale. For every 1 inch of mercury, we have 25,400 microns, so as you can see, it's a much more accurate scale. A reading of 500 microns is now considered a deep vacuum. Thank you for your time, and I look forward to module number 3.